Hello pre-calculus students, and welcome to a video on half-angle formulas. This is the first of a series of 9 videos on half-angles, and the first video doesn't even lead to half-angles. We're just going to kind of look at how we're going to get from the sum and difference formulas, which you see over here on the right. So we're going to use these sum and difference formulas to eventually develop the half-angle formulas. Now the other formulas along the way are also important, and let me just kind of peek ahead here. These are the formulas that we're going to get to. So far, we've finished the sum and difference formulas, and we're going to go from today, right now in this video, the double angle identities, and then from there we're going to move on to the power reducing identities, and then from there to the half angle identities. And we're not going to cover the ones at the bottom here, the product to sum, but basically it's going to be something like this. So we're going to go from the sum and difference and right now to the double angle formulas. Okay, so let's see what that looks like. From here. Okay, so first our goal is to come up with a formula for the sine of 2 theta, the tangent of 2 theta, and the cosine of 2 theta. You'll see at the end why they're in that order. And we're going to use the sum formulas for each of these. So here's the sum formula for the sine, but now imagine that alpha and beta are the same thing, and we just call them theta. It doesn't matter, they're all the same angle. So we're just going to apply that formula. So the sine of 2 theta would be the same as the sine of theta plus theta, which would be here sine theta cosine theta plus sine theta cosine theta, right? In other words, it would be 2 sine theta cosine theta, and that's the first formula. So the sine of 2 theta is 2 sine theta cosine theta. Okay, let's look at the tangent. So we're going to use the tangent formula, and imagine again that alpha and beta are both theta. So we would end up with this being the tangent of theta plus the tangent of theta over 1 minus the tangent of theta times the tangent of theta. So that's just 2 tangent of theta over 1 minus tangent squared of theta. And there's the tangent of 2 theta. Here's the sine of 2 theta. So we've got 2 identities here so far. Now let's do the same thing with the cosine and see what happens. So with the cosine of 2 theta, we're going to get a couple of options here. We're going to start out just applying the formula, and since alpha and beta are both the same thing, we're going to get the cosine of theta times the cosine of theta minus the sine of theta times the sine of theta, and that's one of them. If you just call this cosine squared, so we would get the cosine of 2 theta is equal to the cosine squared of theta minus the sine squared of theta. So that's 1 of 3. So this is one of the cosine of 2 theta identities. But we're going to use the fact that sine squared of theta plus the cosine squared of theta equals 1. No matter how hard you try to get this established identity here to look like this, there's nothing you could do to make it minus. Okay, but what you can do is you can rewrite the cosine squared as 1 minus the sine squared. And so one alternative for how to write this would be the cosine of 2 theta is, and we're going to replace the cosine squared with 1 minus the sine squared. So 1 minus the sine squared of theta minus the sine squared of theta gives us 1 minus 2 sine squared of theta. And so that's one of the options. Okay, that's this is number 1. This is number 2. And now I'm going to pause the video and see if you can come up with number 3 by replacing using this in the other way. So think about what that might be. Okay, so there's the third version of the cosine of 2 theta. Again, all I did was I took the original version, version number 1, up here, the first one up here. There it is showing up. And I just replaced the sine squared of theta with 1 minus the cosine squared of theta right here, and then careful with the negative signs, and this is what you end up with. Okay, these variations of the cosine of 2 theta are going to be helpful in going to the next step of getting the half angle formulas. We're going to use the double angle formulas as well as the half angle formulas, so that will be coming up in some future videos. Okay, hope you found this helpful.